Start recording. So, hello and welcome to your Cloud Native Social Hour. My name is Nicholas Lane and I am your host as always. I'm joined in the office by my friend and colleague Kushik. And this is actually going to be the last time we're going to do the Cloud Native Social Hour in our inaugural studio, the boardroom of Heptio, from Heptio Towers. I know, it's sad, Duffy, it's sad. But yeah, so the Seattle office, the VMware Seattle office, aka the Heptio office, is going away very shortly. And so this is the last time we're doing it here. And I know it's a nice space. We got like a pile of junk over here that we never really ended up using. But I think that'll be joining us in Bellevue somewhere, like stuffed in a corner. And yeah, we'll be doing it out of various conference rooms in Bellevue from now on.
Yeah, I think TGIK is also moving there.
Yep.
So I'm assuming TGIK should be the last episode for Chris.
No, I think there may be one more here. I think it's the second week of May is the current tentative plan. I know this is recorded, but don't hold me to that. I have no control over these things or any understanding, but I know that for me, this will be the last time we're able to do this because the second week of May, I'm going on vacation. So it'll probably be well after I'm back. We'll have moved to the Bellevue office. But thank you for joining me and the rest of my friends from the Kubernetes Architect team and here at VMware. Jesse, what's up?
Hey, Nicholas, how's it going, man?
Doing well, man. We're just saying that this is the last time we'll be able to do this from the Heptio office, from Heptio Tower.
Is that it? Is it done?
We're coming to the end, but also I'll be going on vacation sometime around when we're moving, and so logically this is the last time. So
makes sense.
Too bad. Yeah, too bad, but it'll be good to kind of have a new home and get settled in there. All right, so this time on the Cloud Native Social Hour, we are talking about chaos. As I said in the internal email, we're eschewing the gaudy trappings of stability and introducing a world of randomness to our infrastructure. This is something that I've only recently become, I've been always interested in the idea, but I've really started to look into it more actively recently and trying to do some of my own chaos development and stuff like that. And so I kind of wanted to talk about it this week. I organize this thing. I'll set the topic whenever I want, damn it.
Yeah, I think chaos, I call it resiliency testing for Kubernetes and just ensuring we are getting things done in the right manner, like Kubernetes is working as it is intended to work. So I call it resiliency testing, chaos testing, just to ensure everything works as expected.
Yes. So. Well, but before we jump into our main topic, is there anything that anyone is interested in the cloud native ecosystem in the last couple of weeks? Anything that really piqued your fancy? I actually haven't had too much of a chance to look into new projects or anything that really intrigued me. Actually, the last time we kind of went over this segment of things that interested us, it was around chaos. Hart, what's up, Hart? It was around chaos, and actually, Duffy, you're going to be doing a demo on that very topic.
Oh, yeah.
Yeah, I'm excited. I want to see how it works. I haven't had a chance to really dig into it. But yeah, anybody else? Anything that really stood out in the cloud native ecosystem?
Few hot topics for me lately have been I've been having a bunch of weird network timeouts. So of course, networking and cloud native is always good. But also we're talking about storage lately and persistence. And then also there's a thing coming up through the CNCF. They're doing some sort of webinar about that, persistent services. So that's kind of that's me kind of getting into that a little bit.
Cool.
So I know there's like Rook out there, but which is, I mean, it sits on top of Ceph, but I was wondering if there was anything else out there.
So this is actually a good. I have a good answer to that. I've actually not gotten Rook to work. I know that the team was working on Rook are a lot of like they're really smart people, and I think that it's a great tool. But I personally have never gotten it to work. So one that I've turned to for if I need something like Ceph is OpenEBS. I keep talking about it. I'll continue to keep talking about it. OpenEBS is a really cool storage tool. That rhymed. I'm a cool guy. So basically the way it works is it uses the ephemeral storage of each pod to create a Ceph cluster. And so you're like, oh, well, what happens if a pod dies? If a pod dies, a new one comes up, and the Ceph cluster migrates the data and makes sure that you have quorum still. So you have this kind of cloud-native storage solution that can grow and expand with the number of pods that your cluster allows for. That being said, it also takes up compute and other resources that you might be competing with, but I think that's a really handy tool, particularly for prototyping.
Yeah, agreed. There are some others out there. I'll second the vote for OpenEBS and for Ceph. They're both pretty decent. If you're looking to pay somebody for storage, which is probably not a terrible idea because it's storage, so it's always it's obviously going to be pretty darn important to you in the long run or in the short run, either way. There are some other ones that I've seen customers have pretty reasonable success with, things like Portworx, and there was another one. There were a few others out there. Portworx I like because they actually are one of the few that I've seen that has the idea of encrypting at rest, so you can have volumes of Portworx that are encrypted, which is pretty neat.
That is.
Yeah.
That's something that comes up a lot too, is like encryption at rest, and I haven't really seen a good solution for that. It's usually like kind of something baked in, and it's cool to see that Portworx is working on that. I'll have to check that out.
Me too.
Anybody else? Duffy, you got anything cool in the cloud native world?
Oh, yes, actually. So another one. They probably talked about it a little bit in the TGIK this week, but there was a blog post on Kubernetes blog. Let me find that real quick.
Sure.
One second. Q Weekly. That's a great thing that happens weekly that put on by the CNCF ambassadors called Cube Weekly. I use the heck out of this thing to understand what's actually happening in the ecosystem, and they just linked this thing called Cube IP Tables Tailor.
Yeah.
Yeah.
For network visibility.
Yeah, network visibility, Kushik just said.
Yeah. I'm super impressed by this idea. I haven't played with it yet. It's definitely on my list of things to do, but I love the idea of it, because effectively what Cube IP Tables Tailor tries to do is if you set a log entry or log line on failed packets at the underlying node, they've written into this daemon set a mechanism that would allow you to annotate the event of a dropped packet for any given pod. So if you're seeing packets be dropped maybe on purpose because of network policy, or maybe you're seeing packets get dropped because of, a number of different things, this seems like a pretty interesting way of exposing useful information up at the event stream. So I was kind of impressed by that. And again, I haven't exported too much, but I was really kind of impressed not only by this idea, but also just kind of by the design pattern. The idea that there may be more information that you want at the pod and that you would like to expose, kind of generally at each kubelet or node layer that you want to expose as related to what's happening with the given pod. And I thought it was a pretty interesting pattern.
Nice. Yeah, that's something I definitely want to look at a lot more.
If you look at, there's another blog post that they have written in that same page. If you look at, there was a box trying to do for the control plane. That's a pretty nice function. Like they were looking at doing like reporting errors from the control plane to applications using, it's kind of up there. Yeah, this one.
Yeah, same pattern. I haven't looked at this yet. But yeah, this is that's exactly what I'm talking about, right? I like this.
This is why I brought you out here. This
Aggregate.
really seemed neat, something that we should probably think about.
Mm-hmm.
This is pretty cool. All right. Cool. If you don't mind adding these to the HackMD, these links, I and for everybody who's joining us would love to follow along. Like I definitely want to check this out, and I will forget about it because I'm a forgetful person.
I know, and you gave me the HackMD link and everything, and I just have to find it again. Hold on.
It should be in the social hour Slack channel inside our private Slack channel.
Exactly. All right, cool.
So, anything else that anyone's interested in the cloud native world?
This week for me has been a little interesting because I've been exploring Showback and Kubernetes.
Oh yes, okay.
And,
classic topic.
Honestly, looking at number of solutions out there, it seems a little limited. I did explore operator metering, quite heavyweight for what it does or what is expected from the customer, but it does work. If you look at monitoring the resources and putting a dollar value against the amount of resources that you've used in your cluster, Prometheus does store a lot of this data, but because of it being not a long-term storage option, there's a limitation on how much data you can get from Prometheus. And that's what operator metering decides to solve. Like they have their own database that you have to install and where you could get data out of it, and then like report costing based on if your application is using this much amount of CPU and this much amount of RAM, and then put a dollar value on it so that can be billed back to whichever lines of businesses are deploying that a particular application. So there's another, while exploring this Showback, I also came across a small company doing KubeCost. KubeCost is another way of doing Showback in Kubernetes. And if you look at VMware solutions, we have something, what is that called? Cloud Health.
Oh, Cloud Health, that's right. Yes, the SaaS offering.
Yeah, that's a SaaS offering. So something to do with on-prem is what my customer is currently looking at. So we are exploring all options around Cloud Health, KubeCost, and also the first one, which is operator metering.
Okay.
And then, yeah, these are some of the things that I'm working on. So
nice, and I'm glad to see that there's been a bit more traction in that in the community. Like this has been a question. When I said this is a classic question, it's something that really hasn't been solved yet. Like a lot of people handle it through like Prometheus or Grafana metrics. You know, you can take a Prometheus metrics and multiply it by some amount, and that's the amount that you owe, right, to the resource. But there are issues with that. Kaushik, I remember we were talking about this where Prometheus loses data if your step of data is big enough. It will just drop data, and it's not convenient for that purpose. It's more better for like point in time series. So I'm glad to see that there's some other companies that are working on this. I know Thanos, speaking of Endgame, I know Thanos is another tool in this arena, right? It's a SaaS offering for Prometheus. It's like long-term Prometheus storage.
yes,
Yeah.
and it also does your HA aspect of it, which is great. And that's also another solution. We were writing some scripts, custom scripts, to pull data from like a long-term storage. Like if Thanos actually works,
Yeah.
we're looking to use Thanos and then use this custom script to pull out data. But that would be also another solution to look at. But honestly, operator metering is in alpha.
Yeah.
And it's been in alpha for like 2 years now. So
They're being very cautious.
and KubeCost is great. It's very much a lightweight solution, but that's also an alpha, but they have their own Slack channel and they're very responsive as well.
Cool.
They're doing pretty good stuff there.
Yeah. That's worth checking out. I'll definitely check that out. All right. before we move on to our topic at hand, I'm going to introduce a new segment to the show. Nick's song recommendations. I've been listening to a song this last week called Drunk Drivers / Killer Whales. The Killer Whales actually doesn't have anything to do with the song, but they like scream it at one point. It's by a band called Car Seat Headrest, and it's just this really fun, kind of cool song. Well, I guess not fun. I find it fun, but it's kind of about a person who is going through what sounds like a breakup, and they're like convincing themselves not to drive drunk, and they're like, screwed up in the head, and they're like going through this terrible moment, but they're like, it doesn't have to be like this, and I just really like it. And so if you want to check it out, I highly recommend it. Car Seat Headrests, Drunk Drivers / Killer Whales. If you want to like crank it in your car and scream it, it's a perfect song for that. Anyone else have any songs they're listening to right now that they're kind of catching their fancy? I've been saying that a lot recently.
Yeah, I've been listening to some kind of like blues stuff lately, but I wouldn't say I have any particular ones that jumped out at me. Lately, I've been kind of on a Ray LaMontagne kick, which is got some really good stuff. I remember when I first heard Ray LaMontagne sing, I was like, I was trying to picture this dude in my mind just by listening to his voice like you do, and I was way off. He didn't, but I've seen him in concert a couple times with my wife, and he's tremendous in concert. So if you get an opportunity, I definitely recommend checking that out.
Yeah, I kind of had a similar response for a couple of bands. This is going to be me being bad at like identifying certain things, but I had the same experience with Tracy Chapman. When I listened to a Slow Car, I thought that was a man singing. I didn't know that it was a lady.
Yeah.
And looking back, I'm like, why did I think that? How could I possibly have thought that? But for the longest time, I thought that was a dude.
Well, that's kind of the amazing thing, right? It's like we're pattern recognition machines generally, right? So we always kind of want to try and like in our head, even if we're not realizing it, we try to categorize the things that we see and we hear in terms that are reasonable for us, right? And they might be totally off, and like it's always kind of amazing when you think that you've got something figured out, and you're like, nope, I wasn't even remotely close, like.
And I think that's a good point, Duffy, and it's going to drive us directly into the topic of the discussion, which is chaos engineering. And a part of chaos engineering, a very important part of chaos engineering, is data recognition and monitoring. And I think that's something we're going to talk about in just a second. Kushik or Duffy, if you have the HackMD available, can you add it to the Zoom chat? So that there's a part of the HackMD called Twitter handles for gratuitous follow requests. It is Follow Friday, as you know. So if you would like to add your Twitter handle to the end of the HackMD for this episode, let us try to join together and see what each other are talking about. Hello to our new followers. We have a couple of people joining us. I'm assuming TGIK just ended.
Oh, she's still going.
Oh, she's still going? Oh, okay. I just made some spike of people who joined us. I'm like, oh, I guess TGIK ended. All right, so this week we're talking about chaos and chaos engineering. So I first became familiar with chaos engineering when I heard about like the way that Netflix handles their infrastructure. They have kind of this interesting idea where, and I heard about this originally when I was working mostly with VMs, back when I was at Red Hat doing like cloud forms and RevM, which is the Red Hat Enterprise Virtualization Manager. And so one of the things that Netflix was touting was the idea that no VM should last longer than a day. And they handled that by introducing chaos. They have a mechanism that would like periodically just go and destroy random VMs and see what happens to their applications. And so ever since then, that's been something that's been kind of on my mind to check out. And now, recently, I've been really starting to dive into it a bit more. And Chris Nova's book, Cloud Native Infrastructure, goes into the role of chaos in your environment as well. And I highly recommend checking that book in general. But that part in particular, I found it to be incredibly fascinating, really easy read, and a lot of good information about how to introduce chaos. And so basically what chaos means, or in this, and I'm sure most of us are familiar, but just to go over it again, like chaos engineering, the idea is that you introduce logical or predictable chaos into, like, instability into your infrastructure and into your applications so that you can see what happens. So basically the idea is that how do you measure the stability of your application, of your infrastructure, if it isn't tested at all, right? So if you have infrastructure that never goes down, what happens when it goes down? Are you able to recover? What's the mean time to recovery? All of these things are important to test out. And if you don't do it, if you're precious with your infrastructure and your applications, something catastrophic will happen because we live in a wild world. By the way, that was a Cat Stevens reference, huge fan. It's a wild world and you will get the rug pulled out from underneath you. So this is something that I think that is very important, and I don't see it a lot in practice.
And which should ideally be like, I think I tie it up all the time that we discuss it with customers. Once we get into some sort of clusters are up and running, they're fine, they're deploying applications, this should always be part of their testing before they get into production.
Yeah, I totally agree. So it's something called day 2 operations, and it seems like, to me, a lot of people never get past day 1, right? Day 1 being setting up your infrastructure, setting up your clusters, all those things, deploying your applications. And it seems like people don't really get past day 1 and get into day 2. Day 2 being monitoring, logging, and chaos engineering. And it's something I want people to be braver about. Like, jump into instability, like have it be part of your day 1 or day 0 operations if you can, like during your setup phase, like try and like record all the things that failed along the way and then fix them, either through procedure modification or through automation modification. I think those things are very important. Anybody else? Do you have any hot takes on chaos engineering?
Yeah, and I agree with most of what you said. I think that, you know, I think another way that I kind of internalize like what chaos engineering is trying to do is that we are, all of us, in the field of computer science, which means that, like, we should be applying science to the work that we're doing. We shouldn't just be like throwing it out there and see what happens, see what sticks, that kind of stuff.
I love that phrase, that idea. We should be applying science to the computer science.
Exactly.
Right? Test out your hypothesis. My hypothesis being that I have a stable cluster.
Exactly. And that's where I feel like the chaos engineering piece really kind of comes to the fore, is because you might develop a theory, a pretty obvious theory, that like if you have 2 instances and one of them goes away, you're going to lose half your traffic. But when you get into the science part of that, that's probably true that you're going to lose about half of the availability of that service. But for how long? And what does it look like empirically to when the deployment spins up that new instance? And like, you know, understanding the characteristics of these applications, especially at scale, is, I think, critical to your success in this cloud native world. You know, and that's where I think that chaos engineering really comes into play. One of the things that I'll point out, though, is like it's interesting. Like the engineering part of chaos engineering, I think, is also pretty important, right? Like anybody can write something that will introduce chaos or troubleshoot or trouble into a system, whether that thing that you've introduced is that you're just going to randomly kill pods, or that you're going to increase latency, or, you know, whatever those things are. It's all pretty easy to actually generate kind of these, you know, insert errors into a system. Sometimes it can get complex if you're trying to like insert a particular error rate, or you want to, you know, patterns like that. Obviously, you could spend as much time as you want in generating the different patterns for that sort of stuff. At the same time, I think it's critical that we understand that when introducing chaos, that even in patterns like Chaos Cube and those things that are out there, that we have to keep in mind that, being able to reproduce the error that you have found when inserting errors into your system is hugely more valuable than just breaking it.
Yeah.
And so, describing that scientific experiment and knowing exactly what you were up to when that thing broke in that interesting way is hugely more valuable than just being able to break it.
I totally agree, because like chaos for chaos's sake is kind of silly, right? It's, how do you test something if you know that the test occurred, or that it was something that is just like kind of outrageous, right? It's like, well, what happens if, suddenly, like, how does our application handle if we introduced a trinary counting system instead of a binary counting system? Well, no one would ever do that. So why would you ever test for something like that? And that was just me being like ridiculous, because obviously there's no such thing as a trinary computing system. But yeah, like if there's no reason for that piece of chaos to occur, or there's no way to know the chaos occurred, it's kind of useless, actually. It's just, you're kind of acting like a child with a magnifying glass and an anthill, right? Just killing things at random for no reason, right? And so
this seems like a good time to bring up what PagerDuty does for chaos engineering. They have like a specific process called Failure Friday, where on Fridays they introduce failure into the system for specific services. They like publish what they're going to do in advance, so everyone knows, and they're tracking everything, rebooting hosts, isolating networks, etc., introducing latency, and then like judge how those specific services react, and then that team can then take that back and like fix that stuff, right?
Nice.
They've their first post on it on their blog was like 2013, so they've been doing this for a while. But it is a pretty cool process that like it's not just kind of like Duffy was saying, it's not random. It's like a process that they do every Friday with specific services and teams. So like, it's coming, but it's a way to like test, and it's like controlled chaos, I guess, if that's a good way to say it.
No, that makes sense. I've actually seen, like, through my investigation of some of the chaos toolkits that we're going to be talking about a little bit, that a lot of them have that control mechanism. Like, you're only going to introduce chaos during this time frame. And I like the idea, like Failure Fridays. Most teams introduce that by trying to deploy to production on Fridays. And and that's how they introduce chaos into the system. No, I like the idea where they're like, instead of deploying anything on Fridays, they're going to try and break something on Fridays. And that's a lot more fun, I think.
Yeah, but it's not just breaking random things. It's like a specific team's service is targeted, and they're running, tests that are published in advance, kind of thing, right? Like, we're going to do these things to your service.
Yeah, that makes perfect sense. That kind of goes with what Duffy's saying. Is like, have a plan, have a hypothesis, and a test, right, and see what happens.
I think there was another tool that Target had developed, which was something like they would kill pods. Like, there's a 25% chance that at this specific time that a pod would get killed. There was also a nice demo that we did earlier. I think Rich Lander had done it, where like if it doesn't get killed, like any pod doesn't get killed in that first time frame, where there was a 25% chance, the next turn would be like a 50% chance that you would kill a pod. So they would introduce like chaos into chaos testing.
Oh, that's interesting. Like, yeah, chaotic chaos testing. That's kind of, all right, I dig that. So you never know exactly when it's going to happen. That's pretty cool. And so kind of something going along the lines of this that we're talking about is the need to measure these things. So chaos for chaos' sake, as we said, is kind of useless. having some control around your chaos, like knowing the time frame that this is going to occur, that's valuable. It's also it's not a bad idea. Like, it depends on the philosophy that you want to go in. To define, like, do you want to live in an unstable environment all the time, but make sure that these things are measured, or do you want to do it during during a time frame so you can get all that data very quickly? I personally kind of enjoy the idea of living in an unstable environment. At the same time, I also apparently don't like having free time or, like a weekend or anything like that. I like the idea that if you're constantly living in an unstable environment, the application that you're developing, if you're doing iterative processes properly, should be more and more bulletproof as you go on. Kind of adds to the agile mechanism, the agile ideology a little bit. If it doesn't survive this test this time, how do you make it so how it survives that test the next time, right? Someone just pinged me. Can you, in TJK channel, Chris wanted to ask a question. Do you mind respond to that?
Oh.
Sorry, it's a little inside baseball. So I got distracted now. I can't remember the point I was trying to make. So measurement is important, and that's what we're saying. So do you want to measure things all the time, or do you want to measure them during a specific hour? And how do you measure chaos? A lot of people use monitoring tools like Grafana or Datadog, like Prometheus, honestly, Prometheus, Grafana, or Datadog, or any of these other monitoring tools, and keeping a track record of okay, during this time frame when we knew that chaos would be happening, what happened, right? What happened to our application? Did we lose X amount of traffic? Did we lose X amount of pods, service, those types of things? And this is something that I actually don't have a lot of experience in. I'll be honest, I'm only, like I said, recently getting into chaos engineering, and also more into monitoring development. I've only really started playing around with Grafana. I love Grafana now. I actually very much enjoy it, but I don't know the mechanism well enough to create a good dashboard for chaos engineering. And I'm kind of curious if any of y'all out there have kind of a dashboard that you've used or created yourself for chaos, for monitoring in this capacity.
I can't say I have anything good, but
I didn't ask for good. I said I asked for something.
Well, usually what I tend to monitor is the kind of the golden signals for what you always want to be monitoring for to really let you know something's going wrong. Errors, latency, throughput. There's one more, and I'm not remembering it, but if you're monitoring for those things, the impact of the chaos will become pretty evident. Errors start to go up. Okay, so when we did this thing, that clearly caused errors. Or my 95th percentile latencies have gone from 700 milliseconds to 5 whole seconds. It's that was, let's not do that again. And also let's restart the state of the service to kind of clear that out.
Or let's not do that again. But it's more like, how do you fix your tool or the tools that you're using to handle the chaos that got introduced? That's something I want to talk about in just a second. But the idea, there's the idea here around monitoring, and you're saying errors, these things you need to track. These are kind of the well-known paths, errors, latency, health, pod health, or just application health, what processes are running. These are the things that are kind of the key triggers. But for each application, you can do more specific around for chaos engineering. These are the metrics that this application cares about, right? It's did you introduce chaos into your database? What, how many rows were changed over what time frame, right? That sort of thing. So we can add more complexity to the monitoring. One of our colleagues, Brian Lyles, recently tweeted about how many people think monitoring or observability is just deploying Prometheus? And how many people think that it's a mathematical function? It's like kind of a, bring the math back into observability. But I saw that and I was like, hey, shut up. I don't do that. How dare you call me out so directly, Brian? Damn.
Yep.
But it's true. Like to me, up to this point, to me, observability was the tools. But I like the idea that it's the math, actually. So you see like aggregate errors over time, aggregate throughput like affectation over time. Doing this like rigorous mathematics around your system to see truly what's occurring. I find that endlessly fascinating, like really, really cool.
Mm-hmm.
Unfortunately, I couldn't get the login details because the TGIK ended, but Chris is going to retweet it.
Okay, great. Excellent. Thank you for taking care of that. We're just getting a blow up from Chris Nova on TGIK. We're trying to figure out how that's going.
I was going to say, I think observability is an interesting term, and I think it's kind of come, I don't know, it's come to mean a few different things, and it kind of depends on, I guess, the consumer of what that term might be, right? So, from the perspective of Jesse, or somebody who's doing SRE, site reliability engineering, that sort of thing, then observability means being able to find some percentage of transactions that move through the system in a way that gives you a capability of understanding how each of the components as part of that system are operating, so that you can actually find that needle in the haystack. You can actually find where things are broken. It isn't just metrics. It isn't just monitoring. It's more than that. It's like, being able to actually instrument your code in such a way that that the places where you make calls to systems that are external to your own are measured, right, and in a reasonable way, so you understand. Okay, well, I know that there's an error in the system. My availability is down. I need to be able to determine, where in this gigantic haystack of services I have is the actual problem happening. Like, where am I incurring this latency? Or if I wanted to observe the entire transaction lifecycle of a Google search, how would I go about that? That's where there's a ton of stuff in this space right now, and it's all pretty interesting. There's some interesting work being done by the open tracing folks, and they're kind of in Zipkin and Istio, and kind of all of these things all kind of fit into this space and trying to wire all that up. But I would say, so for me, it's definitely a loaded term. I think it's it's more than monitoring. It's more than metrics. It's more than logging. It's the ability to really observe the system, the behavior of the system under test.
Yeah.
So do you believe that the three pillars of observability, them being metrics, tracing, and events or logs, do you think that encompasses everything, or is there more?
I do, but each of those is a glacier, right?
That is very true. Yeah.
Right? I do think you could say those three things get it, but at the same time, the depth of each of those things is nuts,
Oh yeah, no, it's massive, and there's some really incredible tools that are coming to the forefront, for kind of figuring some of this stuff out. You mentioned Datadog, and then there's Honeycomb.
Oh yeah, I didn't mean to check them out.
Yeah, it's a startup still, but Charity Majors, who has talked a lot about monitoring and observability and stuff like that. She's the CTO, and it's really the idea is that they
background too.
Yeah, definitely.
Charity isn't just somebody who talks about it. She's been in the trenches. She knows exactly what it is, the problem that she's trying to solve. And I think that really drives a lot of legitimacy and credibility into the project that she's working on.
Yeah. So It came from she was at Parse that got bought by Facebook, and then once she moved to Facebook, she saw that they had this tool. I think it was called Scuba, but basically they were able to diagnose once they instrumented their application. They were able to diagnose problems like within minutes, versus whenever they had their limited tooling at Parse, it took them hours or days. And so she wanted to take that to the larger, she wanted to kind of make it available to everybody. And so, she and a team got together and wrote a specific data backend to do high cardinality searches and queries and stuff like that, which is kind of really what they're building their whole message on is, we're here to let you search like high cardinality data.
Which is definitely one of the challenges. It's interesting, just as an example, like a little explanation into like what cardinality is, because I think this is actually one of the most fascinating things. Like, if you've ever seen a histogram that breaks, like a bucket-based histogram, right? Something where you're looking for error rate, you're looking for error values from an HTTP server, right? And you have error values that fall into 200 to 300, 400, 500. That's actually why they're kind of broken up by the category, so that you can kind of categorize different classes of problems or different classes of results from a web server. One way to do that, get it to a place where you can understand it in terms of a graph, is to bring this idea of like a bucket-based histogram, where you break it up like 100, 200, 300, 400, 500. And that histogram speaks directly to cardinality, because effectively what we're doing is we're taking the value and putting it in one of 5 buckets, and now you only have as much detail around what the error code was as the name of the bucket, right? So in our case, I know that there were 200, 500 errors, but I don't know which of the 500 errors it was. I just know that it was somewhere in that 500 field. I know that I have a bunch of 200 errors, but I don't know if it was 201 or 202 or 301 or 204. There's a lot of detail that goes missing there. And so the value of a high cardinality database is that you can do things like say, you know what, I want to gather all of the information at great depth and be able to interact with that in the way that you might like with a MySQL database or some such, right? Where you're no longer trying to abstract away the amount of data that you have to store, you're storing all of it, and through that high cardinality provide you the ability to kind of like filter down into exactly the error that you were looking for. Like, if the only metric I was gathering was a histogram of HTTP errors, and one of my developers came to me and said, I think that there's a problem where we're returning way more 204s than 200s. I would have no way of knowing that in my current metric implementation. I just know that there's a bunch of 200 type errors. And so that would mean that as somebody on the observability team, if you will, I would have to go in and kind of re-instrument that metric for that application for this period of time and get into that detail. And this is where I think Honeycomb's on the right track, actually. Another good friend of mine, Ben Hartshorn, is there, and he's been there since the beginning. And he came from Linden Labs and kind of solving that problem there as well. So, yeah, they're on the right track. They're looking at the problem, in my opinion, correctly. But it's good stuff.
Nice. Yeah, definitely want to check them out. Honeycomb. I'm gonna give that a look at. So kind of one of the things we keep kind of talking about, and it's like, how do we define what is the kind of goal of chaos and monitoring and all these things? And it's confidence. Confidence is what we're trying to test for, right? It's, do you have the confidence to do your job, right? The way that you want to do it, right? Do you have the confidence to be able to recover from an outage or to withstand an outage, right? All of these things give you confidence. And a lot of times, I think that when we deploy applications, we don't have that confidence. At least I know, sometimes it happened to me earlier today. I had a Kubernetes cluster running last night. It was totally fine. It was in AWS. And then for some reason, I woke up this morning and 2 of my nodes were restarted. And they were both 2 of 3 of my control point nodes. And so I was just like, ah, crap. Like I didn't have any time to like go back and like figure out why they restarted. Because like once they restarted, I also haven't set up the mechanism to rejoin them to the control plane yet. I just ran out of time with that cluster. And so they aren't tied in any way to anything that will fix themselves. And so now I've just got a broken, well, not broken, but a almost broken Kubernetes cluster and 2 superfluous nodes that are just sitting out there that are tied to an autoscaler. And so like I have no confidence in that cluster. I don't know if it's going to be able to survive itself. What if those 2 of those nodes were my etcd nodes, right? And then suddenly my etcd is down. Like I have no confidence in that cluster to be able to continue to run because I have no monitoring around these events that occurred, why they occurred. I have no idea. And so it's what got introduced to me was pointless chaos. Chaos with no function behind it even remotely. And I'm just like sitting here in the lurch like, if I were like going to production in this environment, I would be tearing my hair out right now. This sucks. This feeling sucks. And it's just some dummy cluster I set up earlier this week. Imagine if I was running like my entire business on this. Awful. What an awful feeling. I have no confidence in this. And so these tools and this practice help drive confidence and resiliency. As Kushik, you were saying, chaos engineering is resiliency engineering, right? It's how do you stay up?
And we're kind of almost testing out Kubernetes. It's a declarative platform.
Or whatever application you're doing,
Yeah, we're just trying to break things and ensure that whatever we're trying to break comes back online and working as intended.
Mm-hmm. And that's the other aspect. There's a final aspect to chaos engineering that doesn't get executed on a lot, but I think is the most crucial part. Improvement. It's constant improvement. So like chaos engineering gives you confidence. But in like for the example of my cluster that just went down, what do I do now? What I do now that I've seen that this failure occurred, I want to resolve or I want to develop automation to make it so that that doesn't happen again. So that if these nodes go down, my cluster stays running the entire time. Or if you introduce chaos and there's this threshold spikes, how does your application survive these threshold spikes, right? These like infinitely growing like use of network, right? Or infinite growing use of memory. How do you either kill the pods that you don't want? How do you like mitigate your traffic such that it avoids that like erroneous like endpoint? Chaos engineering should lead to improvement of your infrastructure and your applications through these tests, right? If your hypothesis is like, I believe that my cluster is stable, and then I test it through chaos and find that it's unstable or it doesn't lead to resiliency, then that means that my test failed and I need to introduce steps to fix it. And that's the part that I really, really like. I love the iterative growth that chaos can quickly give you, right? These outages that you control yourself versus outages that the world control for you, right? Let's say you have an application that's running in US East 2 and it's 2013 and US East 2 went down for 3 hours because someone fat fingered an S3 command. That is chaos that got introduced for you, and how do you resolve that, right? That instance doesn't happen that often, but if it were me, I'd be like, okay, cool. Now I see that this application or all of my applications need to run in many regions, and then how do I facilitate that? Through automation, through networking, through infrastructure, right? But hopefully we don't go through too many catastrophic outages like US East 2 going down. Hell, if US West 2 went down, right now, like all of my clusters would be down, and that would be pretty not great for me. And I'm sure that should be pretty helpful for everyone.
There was actually a lot to look at, especially around chaos engineering with regards to that particular S3 outage you mentioned.
Mm-hmm.
Because if you could think of like doing that, in a like it was done actually during the day as part of like a normal operation, but like you said, someone gave it a input that caused the system to kind of go down, it's like, well, people were like, oh, well, you should be validating your inputs, you should be, like doing all this other stuff. And it's like, yeah, so, everyone's learned this because it happened. But the takeaway there was that if you think of it, like, if you control the variables, and you could have kind of everybody watching and everybody looking at the system, when you start to introduce this chaos, especially if you've set up, like, if you've given yourself the allowance to maybe introduce some of this lack of reliability, right? I'm not going to say error budgets, but that's kind of what I'm talking about. So, just because what they learned also was when they tried to kind of get this underlying systems that supported S3 back in line, what they realized is that they had never restarted, like, at least the number of nodes. And so they were unable to come back up online because as soon as they're all JVMs, as soon as they'd come up online, they'd get a whole ton of like assignments of data to manage. It would send the JVMs in like a GC loop, like it would cause them all to crash. So they couldn't even bring up new capacity because they were already running at a diminished capacity, and they never tried to, work under that type of situation. So this is kind of something else that comes out of chaos engineering, is like, you're doing it during the day, you're doing it when everyone's there, versus in with actual chaos whenever it's going to be at 2:00 in the morning and you can't find the person who's on call for the thing that's not, that's not responding.
Yeah. That's a very good point. Yeah, it's like, if you've never tested out, it's not even automation. If you've never tested out your procedures for how do you do this, like how do you recover, how do you have confidence in those procedures, right? It's like, oh, this is the step for how do you recover from, like, this Kubernetes cluster's down, right? How do you get a Kubernetes cluster back up? Oh, we'll follow this checklist, right? But if you never test that checklist, how do you know? And if you need to recover from an emergency state and you've never done it before, it takes so much longer than if you've done it before. If you have that kind of, like, I wouldn't want to go through a recovery state with like muscle memory, right? Just like, mindlessly entering commands, because then you'll end up in the same situation with S3. But having, like, knowing the steps to follow, knowing where to get the information to get yourself back up and running is incredibly important.
And the way that you get better at incident response is practice, right? That's why anyone who, like myself, who has dealt with incidents in the past, that the only reason why we're like sort of capable of jumping into an incident, jumping into like an emergency, and kind of being able to just kind of have kind of a calm approach to it is, it's like, I've been here before. I've been in the frantic, like, oh my God, the world is on fire, like in the middle of the night, and frantically trying to do stuff. You're exhausted because, you haven't slept, and it's like, it is a terrible place to be in. And so that's, that's the conditions in which a lot of people have learned, which are terrible conditions for learning. So why don't we improve the conditions for learning? So then that way, when we start to, and this is how it improves in TTR, right? Mean time to recovery is, you've practiced, you've gone through it. You're like, oh yeah, like whenever it starts spitting out this log, I know what that is because I saw this in the, chaos test that we did like 2 weeks ago.
Yeah.
You start to kind of see all this stuff, and then it improves your MTTR because you're able to think about these things faster instead of like going through logs and then having to cross check that with the line of code that's referred to and say, oh, I see how it's getting there, and stuff like that.
You raised that was a whole bunch of really great points.
Yeah, absolutely.
I want to brush on two of them real quick. So one is, it's true regardless of what you're doing, that you're going to be good at what you practice, right? Mm-hmm. This is how we become good piano players, good bicycle riders, good speakers. We practice it. You're absolutely dead on target for that one. The other piece that I would like to highlight is that I have found myself in a position over the years where I'm trying to teach someone how to troubleshoot. And I've never really thought about it from this perspective, but when you raise this up, if we have a good practice, a good culture around chaos engineering, around understanding the resiliency and characterizing our applications and services, right? Then we are intuitively teaching ourselves a better model for troubleshooting, because when it comes time to troubleshoot, we already know what to look at. We already know how to characterize these systems. And that was well said.
Yeah. Something I wanted to brush on a little bit. You talked about error budgets, and this is actually, that was it. This is a moment where I don't necessarily intend to be a gatekeeper, but I kind of will be a little bit. I feel like you should be hard pressed to describe yourself as an SRE if you don't practice any of these things. If you don't embrace chaos, if you don't want to use the things that you need to do to maintain site reliability, I feel you'd be hard pressed to actually describe yourself as an SRE, despite whatever your job title may be.
I agree.
And like I said, I need to be a gatekeeper, but it's in the handbook. Read the handbook.
It shouldn't. It's not our job to be. It's not our job to be gatekeepers. It's our job to be enablers, right?
Mm-hmm.
So, we're taking two different perspectives here. There's the perspective of, okay, like we've got we've got an engineering team that wants to do this, and then we've got the other perspective of, we know how the system works, and so we know where some of the ideas of these, like the services that are being built or whatever an engineering team is working on, aren't going to be 100% compatible with the way our infrastructure is set up. And so there has to be sort of a alignment that has to happen and say, look, I know you want to do this. Let's compromise, because our system is set up this way. And, while we can get you to the level of being able, we can do this for you. We're not, if we do it in the way that you want to do it, it's going to take 6 weeks, versus if we can compromise a little bit, we could have it done in 2, and stuff like that. And also, kind of relaying, also, we do it in this way because it provides a more reliable system. The thing that came out of this blog post is great for a dev environment, but won't work in a production system. And kind of advocating for the different qualities of a production system, making sure that that's understood by everybody involved.
Mm-hmm. That's it. Thank you. Jesse, do you want to host this? Because you're making some amazing points.
Yeah, but I think just on that note, I probably wanted to tell everyone, I guess everybody knows about it as well, for the day 2 operations, managing Kubernetes by Craig Tracy.
Oh, yeah. Yeah, so there is a Managing Kubernetes book written by our friend and colleague, Craig Tracy. Well, he's one of the authors. The other one is some no-name guy named Brandon Burns. I mean, whatever. Craig Tracy, he's the guy where we follow him. But they have an excellent piece in there about day 2 operations. It kind of goes over a lot of this stuff. I highly, highly recommend it. And also, it's a fun book to read. I haven't gotten through all of it, but every part that I've read has just been, it's kind of a page turner for being a technical book. It's actually pretty interesting to read. It's written in an interesting way, I should say. Because a lot of technical books can be dry and boring.
True.
Yeah, and so also to see one thing you kind of touched on briefly was the idea of error budgeting. This is something I kind of want to touch on as well. If we're going into gatekeeping corner, if you have an SLA or SLO for like X number of nines and you don't measure any of those nines, where did that come from? What is that defined on? And if you say this thing is 5 nines, really what you're saying is that you want 100% uptime, but you don't want to say 100% uptime because that's not cool anymore.
Yeah, I think everyone understands that stuff can't be available 100% of the time.
Yeah.
That stuff sometimes just doesn't work. That's the way life is, right?
Mm-hmm.
but I think what is subtly understated and like just not understood is that I think it's best condensed into the phrase: if you want to add another 9, add another $sign, because the more uptime and reliability that you're trying to get is going to cost more, because that means now you have to run an additional replica of your database in a different region or a different availability zone, and it starts becoming like more and more costly. So I think that but with regards to, and I wanted to break down real quick, like SLAs, SLOs, and SLIs. So the SLA, that's like the service level agreement. People in product and legal and all these people who are mostly not engineers come up with that number. Like they kind of come up with, when do we have to start giving people money back for being unavailable? That's usually the way that I think of an SLA. Like engineers typically should not be thinking of SLAs because their number is the SLO. That's the service level objective. And those are what you define as like, give yourself some padding between, if you're say 99.9%, if that's your target uptime for your SLA, then target like for your SLO 99.99. And that way, if you go over it, you've given yourself enough leeway that you're tapping into your error budget, right? Like, you've gone over budget, which, in the Google SRE book says that's when you don't get to deploy anymore. You don't get to like get any changes out to production, because the reason why is because if you're already over budget, like in any other project, if you're over budget, you need to start cutting scope. You need to, figure out how to get the project back into budget. But this is like a budget that resets itself every month.
Yeah.
And so with those SLOs, those have to come from somewhere, and that's where your SLIs come in, your service level indicators. And so these are the metrics, or whatever you're going to use to determine the number that those SLOs are based off of. And so that's, I think, that's where the error budget is, right? Is it's the area between where your SLO is, like, our requests in the 95th percentile can't be any slower than, like 2 seconds to render a page on a web browser, something like that is what defines your SLO, which, should be supporting the SLA, which is like, if no one can log into the site for more than 45 minutes a month, then we have to start giving people money back,
Yeah. Which is, thank you for breaking that down, because that was something I actually forgot about SLIs. And that those are the metrics that you care about. So when in the process of like deploying these things on customer side, people have asked us like, oh, what are the metrics we care about? Like, I can't define that for you. I don't know what metrics your application cares about to define these things. And so it's good to have that, like the understanding of like the breakdown of an SLA, SLO, and SLI. And so thanks for running through that. That was something that I forgot about. And this is why I don't call myself an SRE, because I would clearly be a bad one.
Yeah, you can actually break it down even simpler. SLI is basically, if you can think of that as, that's your variable. So this is what you're measuring. You don't have a target. Your SLO is variable meets some target.
Mm-hmm.
Your SLA is, if I fail my variable meeting that target, what happens?
Yeah. Excellent. Thank you. All right. Does anyone have anything else to say on the topic of chaos engineering, monitoring, or incremental improvement? Or SLIs, SLOs, budget, that sort of thing.
I want to see a demo.
Yeah, I was going to say, well, thanks for preempting me there, Duffy. No. We're now going to move into the portion we like to call demos, because it's a portion in which we demo things. And so I'm going to be kicking us off with a very short demo. And I don't know if it's going to actually be very useful at all. But this is fine, Doug.
And I have a sticker just for this time of day right here.
Is it this is fine, ship it?
Yeah. This is actually a sticker that Ben the Elder gave me. A good sticker.
Excellent, excellent. So this is the demo I'm going to do is a quick demo of the KubeMonkey tool. I'm not doing really a whole toolkit, just a tool. And the idea, I don't know how valuable it will be because it hasn't actually kicked off what I wanted it to do yet. The KubeMonkey tool is a take on Netflix's Chaos Monkey. And so, like we were talking at the beginning of the show, there's the idea of that Netflix introduced where they restart their VMs or their pods every so often. And that's controlled by a tool called the Chaos Monkey. Basically, it's the idea of a monkey throwing a wrench in the operation. So Monkey or KubeMonkey, basically what it does is every so often, depending on how often you set it for, it will destroy X number of pods or all pods for an application if it's targeted in this way. Just basically every hour or however long you set it. The reason why I think this might not be a particularly valuable demo or like it might not have all the information I wanted to show is that you can only set it up in increments of an hour. And I couldn't have it start running. I finally got my system set up because I've been a busy boy, right around the time that we started the Cloud Native Social Hour, and you can't set the time for KubeMonkey to start at the same time, or you want it to start operating at the same time that it starts. And so I couldn't start it at 2 and have it run at some point in this like hour time frame. So I don't know how. Hopefully it'll have killed a pod. It might not have. We'll see. But I've got at least a pretty graph to show you. So. Also, yes, I'm walking over to my giant screen. If anyone wants to play D&D later, I'm all up for it. All right, let me share my screen.
DM look behind there.
I know. Roll for initiative, Duffy. All right, let's see how this works. Cool. All right, so here on the screen, we have this Grafana page. This is something I set up using kubeprometheus. This isn't a demo of kubeprometheus, although it's pretty awesome. If you have a chance, check out kubeprometheus. It's in the CoreOS repo. And this is just using the example manifests that are there. It provides you with Grafana and the Grafana dashboards that are fairly useful, kind of giving you the building blocks to set up your own monitoring system. So right now I'm in the dashboard called Kubernetes Compute Resources Namespaces Pods, and I'm in the data source Prometheus with the namespace test. And so in test, I just have a bunch of NGINX pods running, hello world. I've got 3 of them. And you see here the color changed at some point. What that was me setting up the KubeMonkey labeling, and I'll get into that in just a second. So I created the deployment, and then I modified the deployment to enable testing on these pods. And so these old pods had to die, and then the other ones came up. Again, monitoring is really awesome. You can see the kind of flow of your infrastructure with this very simple tool, and I find it endlessly fascinating. Anyway, let me, does this change? No, good. That's interesting. So this one will go to, actually. So in here, bam. Can everyone see? Oh no, shoot. Let me change something really quickly. This always happens, I swear. All right, there we go. Can everyone see that? Can read that pretty well?
Mm-hmm.
You can see I'm running Arch Linux. Yeah. So one of the things, social hour. So jumping into the kube config, this is the config map for KubeMonkey, and this is the way you define like how it works essentially. So it takes a toml type config file. It will run, it starts running the destructive tests based on the run hour. So in this case, it'll run at 2 o'clock, and then it'll start at 15, and it'll end at 16. So start trying to kill a pod between 3 and 4. And hopefully I set it up for today. We'll see. I actually might have screwed that part up. That might be why nothing got destroyed. This is what happens when you try and do a demo. Set up a demo the same day you're running the demo. But this is basically how it works, and you can say like, oh, don't run tests in this namespace. I actually should have like forced it to run in this namespace. I realize now. The other one being deployment.yaml. So when you deploy KubeMonkey, there's a repo for it. It's pretty easy to look for, and I'll add the link to the HackMD. But it's here is the image for it. It's under the same repo. And so it is just a simple deployment. They have a mechanism, or they have the manifest there. So KubeMonkey deploys in kubesystem, and it'll run, output this log and into this log dir. And so it was very quick and easy to set up. Boom, boom, boom. And then it should hopefully run at some point in the next hour. And what I was hoping that we would see while we were talking about chaos engineering is you would see a dip in one of these pods running. So this is memory usage. You'd see that the memory usage for one pod went down and the other came up. And regrettably, that didn't occur, but that's kind of the nature of randomness and chaos, is that it is unpredictable. And it's only been running for a very short time as a testing mechanism, but it didn't quite pan out. But so the reason why I wanted to show you this is this is actually kind of the beginning of chaos engineering and chaos tooling. That kind of didn't really kick it off, but is a good first step if you want to start introducing chaos into your infrastructure, is a tool like KubeMonkey, where in a controlled fashion between these hours on these days in these namespaces, you can say what pods you want to destroy and how you want to destroy them. There is, or how many you want to destroy. There is more documentation on the website, which I'll add the link, that will talk about percentage of pods. You can destroy a certain percent of pods or a random percentage of pods. So it will choose anything from 0 to 100% of the pods selected to destroy. You can tell it when to run, what days to run. One more thing I wanted to show off, actually, while I'm thinking about it, is how you define a pod to be targeted. Just taking a second. Oh no. Why? What happened to my... Oh, that's right. There we go. So here we go. So for every deployment and for every pod that you want to be targeted by KubeMonkey, you need to add these labels. So KubeMonkey enabled, and the identifier is monkey victim. Kill mode is fixed. So fixed, basically, kill mode can be percent, random. There's a bunch of these configurations. Fixed basically means that it'll kill only the kill value number of pods. So it'll only kill one pod. And then the MTBF is a mean time before failure or between failure. So this is a value in number of days that'll wait before trying again to destroy pods in this application. So you need to add them here in the labels, and then for the deployment, and then down here in the template labels for the pod as well. So KubeMonkey enabled, identifier is monkey victim. The identifier can be any string, by the way, it just needs to be unique. And then however you want it to be destroyed. Whoops. And then my screen went black for, oh no, Zoom. Zoom suddenly, so something interesting that happens with Arch Linux is that occasionally Zoom will, instead of broadcasting your screen, will create a black box that fills up your screen, and now you can't do anything. So in the meantime, And that was it for my demo. It was just a very simple tool to use, but it's a very good first step to get into chaos engineering in your environment. A very simple tool to use, very easy to control. But as we saw, there's an element of chaos involved in the use of it, and I wasn't able to demonstrate anything particularly.
And I think one of the other options is to like tag it by your application, so that you can target specific applications to be pods belonging to an application to be destroyed.
Yeah. No, that's a very good point. And I think that's kind of what we had that's what the identifiers are used for, is like these ones can be killed in this way. Give me 1 second.
I'm sure.
That I might need to.
Maybe we need to change the screen.
I might need to. Give me 1 second. Shoot, I was hoping that killing Zoom on my local screen would have. Actually,
John is still on the co-host. Maybe.
no. What I'm going to do is remove myself. Let's see that. Did that work? That's crazy. All right. Okay.
Hey.
All right. There we go. So now I can't rejoin Zoom, so that sucks. But anyway, so that was KubeMonkey. Very simple tool for very simple chaos engineering, but good for a start. Duffy, what do you got for us?
I'm ready.
Or actually, let me ask, does anyone have any questions around KubeMonkey or any thoughts around that? Cool.
I kind of was wondering, like, what do you think the goal is? Is it just to see what happens if you lose a pod, or to make sure that your pod's responding to term signals and stuff like that?
I think that's both of those are valid. The main goal of it, though, is, like I said, to follow the Netflix mechanism of just killing VMs. Occasionally, and seeing how the pods handle destruction or how your application handles destruction, right? So hopefully, what I actually wanted to get done is a better SLI. Say, like, here are the error codes we're seeing, or the 404, like, how many 200s, how many 400s are we getting per pod?
I got your back.
Yeah, I was hoping you might have something like that. I wasn't able to get that set up for KubeMonkey, but what I wanted to show is just the destruction. And what I would have liked to have seen is, or show off, is that the application itself, the website, because it's just an NGINX pod, should have been resilient through the destruction. And I regrettably wasn't able to set that up. I just ran out of time.
There was and just to Jesse's point and adding to that, like, there was this nice blog post on Learn K8s about what happens when kubeproxy crashes, right? I think it was about, have you read that? Those IP tables and destroying those IP tables. And there is a value inside the manifest files wherein it is a set of about 30 seconds before which a pod can be rescheduled. And not everybody just takes it as a default, right? You just don't go around messing with these manifest files. These chaos testing tools will tell you exactly what might happen to your production systems if you kill kubeproxy. You immediately know that a pod coming up, it's going to take like 30 seconds, which is the default time, before you can have it up and running.
Mm-hmm.
So those are some of the things that you would uncover when you do this sort of chaos testing. It's a pretty nice blog post. It's about Kubernetes chaos engineering lessons learned. I can probably link it. It essentially talks about the documentation, about the various default, like I think before 1.9, it's IP tables. Now we have IPVS. What values can be changed or can be defined, and make your what is your tolerance level, right? You're looking to discover what your tolerance level is to failure, and then define those values accordingly.
Yep. Yeah.
Sorry, Duffy, I think you had some point on that.
No, I was saying again, like we were talking just about, like, you know, I think to Jesse's question, like what is it used for? I feel like chaos, you know, anything that's going to kill a pod in your Kubernetes system, the goal is to basically just be like one of the elements of your experiment. So in my demo, I'm going to show kind of what I mean by that. Like it's going to be, my theory is, you know, like what the theory is and what we're going to do and how to test it. But to your point, Kushik, I think it's fascinating, and I feel kind of silly. It might trigger me to make like a whole blog series about this, but it'd be really awesome to apply chaos engineering against Kubernetes itself, because I have a completely different theory about what happens when kubeproxy crashes, right? As long as kubeproxy crashes without not being in a write mode, everything's still cool, because those IP tables rules will still persist over time.
So it does rewrite stuff, but it takes about, the rules are refreshed from between 10 to 30 seconds. So sometimes you get the refresh rules are refreshed in like 27 seconds, sometimes 25, whatever. But what is your tolerance level for that refresh rate to happen? It will refresh, but it's your tolerance level. So you can go ahead and now define, okay, I just don't want to wait 27 seconds. I want it to be refreshed in a much faster rate. These are some things that you would consider when you're doing like your day into day two, operating your Kubernetes clusters. These are some of the things that you would want to consider, and which we do not actually.
Yeah. And so to kind of wrap up the KubeMonkey thing, Jesse, you make a very good point. What I really demoed was bad monitoring of chaos.
I wasn't actually trying to make a point. I was just, legitimately curious.
No, you're right though. It was something I thought about after the fact. As soon as you asked, I'm like, this is a perfect example of what not to do. Because my monitoring had nothing to do with the chaos I was involved with. It didn't show off resiliency in any capacity. It was just showing the effect. What hopefully would have happened was it was showing the effect of chaos, but not the effect on the application. And so it was essentially useless.
Well, the important thing is we learned that this was, a poor way to monitor, and that's the point of chaos. Like that's the point of chaos testing.
Yep. Prometheus and kubeprometheus is very good default, but based on a failed test, I now need to go back and iterate on it and make better monitoring for my chaos.
I like it.
Cool. All right, Duffy, hit us.
All right.
I'm going to step outside for just a second.
Why can't I? Hello. Hold on, my screen is kind of locked up. Oh, there we go. Okay. And share, desktop 2, share. Can you see my screen?
Yep.
Great. Maybe the screen size, I guess, the font.
This one? That font?
Yeah, that's good. That's good.
Okay, cool. All right, so my demo is on Chaos Cube, which is a different tool that kind of performs similar functions. I was kind of impressed with Chaos Cube when I was evaluating it. It seems to provide some pretty good, kind of a number of interesting capabilities. It can be deployed with Helm. Before I get too far into how to deploy it, I would like to share that in the HackMD, I put a link to this repository, which is in GitHub. It's under github.com/myname, Maui Lion, under kind-chaos cube. So if you want to, follow along at home, the documentation for how to do that should be here. That's what we're doing here. Okay, so back to this page. Okay. Chaos Cube, this is their repository, their GitHub Linky, Linki, Chaos Cube, and inside of this, they've got some pretty reasonable documentation about how to get started. They have a Helm chart that they maintain. They provide a number of interesting filters, including you can filter by namespace, by label set, by annotation, by age. You can have things like exclusions, right? So you can exclude certain days, like don't do it on Saturday or Sunday. Just reserve your chaos for business hours, please. You can avoid times and days of year. It's got a pretty reasonable implementation. And you can also, and so for my goal, what I was trying to do was actually make it so that Yeah, so that's their website. Before I get into the demo part of this, I want to show this page, which I thought was also pretty interesting. And it kind of speaks sort of to like what we were talking about. And I'm going to put this in the HackMD, but not yet. This is a blog post by a company called LoadMill. And LoadMill is a company that provides a load, an external facing, a customer facing load tooling. And it can actually also help you kind of instrument this thing in such a way that you can understand whether the application is responding in the way that you might expect. This blog post kind of gets into a lot of the topics that we talked about, which is, like what is chaos engineering? What is it good for? How do you go about accomplishing this? And the neat thing about this doc is that it gets into like, the experiment idea, behind it, right? Like we're going to create an experiment, we're going to deploy our application, we're going to simulate steady state, which means that we're going to have, some specific load on the host. Then we're going to introduce chaos. In this case, I think they ended up using the Cube Chaos, the Chaos Monkey one. Soggy was showing up earlier. And then they go back to LoadMill, and because it's actually the thing measuring the steady state of the application, they can provide this really pretty graph that shows like what happened when interruptions happened to the application, which I thought was actually a great little summary of chaos engineering and the way that we've been talking about it in this episode. Kind of like, generate a theory, test it. If it didn't work out, make sure that your inputs and outputs all make sense and that your theory is reasonable. Dig into why it didn't work out or why it did work, et cetera, et cetera. Good stuff. Now, a little bit about my setup. So I am running Kind. Get nodes. I've got 7 nodes and it's just a single master control plane. I'm actually running Metal LB as a load balancer. So if I do kubectl get SVC, I have Metal LB deployed, and so I can create on my Kind cluster things that are load balancers with their own external IP addresses. These IP addresses are part of the same range as the Docker containers that I'm running in Kind. So this is actually how I'm able to access them. I'm running on Linux, which means that these external IPs, because they're part of the same L2 domain as my Kubernetes nodes, are going to be, that it's all reachable. So I can use my browser, for example, to access my application. The reason I'm running Metal LB in this case is because I needed a load balancer that would be in front of my service, right? I needed some mechanism like that so that I could show kind of the resiliency or failure model here. If I just went directly to the application, I would only be showing access to that one application. And I want to see this, I want to show this traffic kind of being balanced across a shared IP or a VIP. And that's why I'm actually using Metal LB for that. A little bit about Metal LB. So in the repository, I have a directory, the Metal LB, how I applied it, that's all in here. And then also inside of this directory, I have a directory called CARD, where I'm actually using kind of the application Kubernetes up and running app with a health check and with a readiness check and all that stuff, kind of exposing it via a load balancer. And I'm annotating the pods.
It's at the top.
In my deployment.
Template, metadata, annotations. Line 24.
Right there. Chaos equals true. And so in this case, what I'm doing is this is actually how I configure Chaos Cube to kill these things, right? So I've deployed Chaos Cube in such a way that it can actually apply this stuff, or that it can find all pods that are annotated with Chaos True, and it will kill them. Now, side note, I actually confused the heck out of myself for a little while, and as I imagine everybody does at some point, because I was applying this annotation at the deployment level.
I do that all the time, Duffy.
Which obviously doesn't do anything I wanted to do, because from the perspective of Chaos Cube, if it's not a pod, it doesn't exist.
Yeah.
So I have to actually apply this down at the template level, and that was it took me a second to figure out. You know, it's a complex world we live in. So that's how that was. We got that all working. That's all in here in the examples, so you don't have to figure it out. You can just borrow my stuff if you want. And that is where we are currently. So if I do get pods, I can see that I have 2 pods for the card deployment and 2 pods for the card safe deployment. Card is actually the one that I'm running the chaos test against. I probably should have named it something other than card. And then safe is the one I'm not actually running any experiments on. And you can kind of see that by the age, right? If you look at the pod age over here for these 4 pods, I've got 2 that have been up for 37 minutes, 1 that's been up for 83 seconds, and 1 for 23 seconds. And if I do a refresh, probably a couple more refreshes, we'll be able to see one of those pods go away. Well, so that is basically what I have set up in my environment. Now for the fun part. So what I was trying to prove was error rates. And this is kind of getting back to sort of that histogram idea that we talked about and some of that stuff. Now, in my test, in my environment, everything is local to me. So I'm kind of just beating up on my own little laptop here. It's suffering under the load just fine. But there are a couple of things happening on the screen on the left that I wanted to kind of walk through. Card image, yeah, okay. So on the left here, what I'm doing is I'm doing a get for 172.17.255.1, which is the card service that Chaos is actually going to affect. And I'm going to use Vegeta, which is a tool that can provide load testing for web applications at a rate of 1,000 requests per second. And then I'm going to pipe that to Vegeta encode, which gives me like the output in a JSON format. And then I have another little tool called Jagger, which is a little Go binary that's going to provide me this 1-line aggregate the massive output that Vegeta outputs and just show me what I care about here, right? Which is that for the status code of the return of the request, I want to see how many of them fall into each of these buckets, right? So 100, 200, 300, 400, kind of like we were talking about before, right? And so I've got that set up on my chaos service, and I also have it set up on my non-chaos service, and hopefully we'll see some differences here between the two.
So Duffy, really quickly, the tool you're using to attack, does that come from Zenart's repository?
From Vegeta?
Yeah.
Vegeta is Zenart, yep.
Cool. So really quickly,
yeah,
it's actually pronounced Vegeta. It's based off of the Dragon Ball Z character. So scroll down. He has a little. Scroll down a little bit. There he is.
There's a meme involved here.
Yeah. So nice. I'm like, is this actually named after this character? So yeah, this is Vegeta from Dragon Ball Z.
Oh, I thought it was Vegeta. That's awesome.
Yeah.
And then I actually got the Jagger thing from this page as well. Like if they were going down to like how to produce graphs and stuff. Like I was actually looking at the real-time analysis piece here, and that's how I found Jagger, which is a way of taking the output and getting just the output that you care about. I thought was pretty neat.
Really cool.
Open tracing.
Yeah, so it creates metrics for you, like on the fly. That's awesome.
Mm-hmm. Unfortunately, when he wrote the JPlot tool requires iTerm, which I don't have, and I haven't looked into like maybe porting this to some other terminal. So for now, all I'm looking at is just the error rate, which is good enough for our experiment here. So let's kick those guys off. And then let's, kind of look at what the output is and see what we're looking at. And I have a couple of different interesting experiments to kind of walk through here, which I think will be fun for all of us. So on the left side, these top two, which are card F44D5, right? These two are running. You can see that they're running up for a short time. And I can see that the vast majority of my error code or my return codes from my HTTP gets are all coming in as 200s or in the 200 range.
Yeah.
But as soon as I see a pod die, right? As soon as I see a pod die, I see my 500 error rate go up. And so what this is actually testing is what happens to the traffic that was being terminated on that pod when the pod suddenly goes away. The pod just dies out of hand. What's going to happen from that queue, kind of that queue proxy perspective, or not proxy in this case? What's actually happening? I guess it would be queue proxy. What's going to happen when I have traffic routed to that pod and that pod goes away during the middle of that call? Right, so I'm issuing 1,000 requests per second across a load balanced IP address. That means presumably that on each way, my availability drops in half, and I see an error rate increase because the traffic that was in flight for that endpoint is now hitting the floor, and that's what I'm seeing in that error rate here. Whenever we see a pod terminate, we see that 500. So that in itself was kind of an interesting experiment. Yeah, and I can also scale this up, or I could scale it down, and then we could really highlight the how that's going to be affected, right? If we scale this down to one pod and we test it, we can really see the 500 errors being affected here.
This is really awesome.
That was one experiment. The other thing that's neat is that another great example of this, which I thought was actually kind of interesting, is when I was setting this up. Obviously, none of my 7 nodes actually had that pod image. Only like the two of them where these pods were initially deployed did. Right. So if I do wide. You can see that right now I'm using KubeKind Worker 3 and 4 for this image. And when I delete a pod, it will get rescheduled to some other pod. And when that happens, if the image was not already available, which by now it is because it's been running on all of the nodes, I have to also incur the amount of time it takes to get that image deployed on that node. So that was also kind of an interesting experiment. And it wouldn't necessarily increase my error rate, but it would take longer for me to get to a place where I had enough budget to support the requests per second that I was trying to satisfy, which I thought was interesting. Okay, so that's this. Yeah. And then the other thing is down here, which is interesting. So on the bottom of my screen, which I should probably make a little bigger, what I'm doing here is I'm actually looking at the endpoints that are behind that VIP, right? So if I do, let's do Control-C here. I'm doing a kubectl get endpoints, which is a command that you can run inside of Kubernetes. And I'm looking at that particular service, and I'm watching those endpoints change. So as a pod goes away or comes back or a new one gets created, I'm watching the endpoints, populate with a new IP. And this explains some of the other interesting behavior that we're seeing here, in that we're not down for a really long time. We're not incrementing errors for a long period of time, because as soon as that pod becomes unready, we stop sending traffic to it. And so there's only a very small window of time in which we will be able to trap those errors, those 500 errors that we're seeing, right? Because as soon as the pod becomes unready, it gets removed from the healthy endpoints of the service, and Vegeta will no longer be able, or Vegeta will no longer be able to actually route traffic to it because it won't be in the running. And so I thought that was pretty interesting. So that was that part of it. Now there's one other test that I wanted to share with you, which I thought was, and this is actually kind of an artifact of the tool that these folks wrote when they were running Kubernetes up and running, is this great little web app that provides a number of interesting things, including a liveness probe and a readiness probe, keygen, memory queue, all that stuff. Now, what's neat about this app is that I can also configure, I can decide whether I want the health or the readiness probe to fail over time. So on the left side, my theory was that if I kill a pod, I'm going to be able to capture some 500 errors, and I proved that I could. On the right, what I'm going to do here is I'm actually going to force a pod to restart by having it fail the liveness check. And my theory is that I will not be able to see any errors, because as soon as it fails the liveness check, it will also fail the readiness check, and it will get rescheduled, and I should not be able to capture any errors. So let's see what happens there. So what I'm going to do now is I'm actually going to start failing the liveness check. And this is somewhat artificial because like the traffic is still able to terminate on the pod, even if its liveness check fails, right? That's not like I've turned off the web server. I've just told it to start returning 500 for the liveness check. And that's why I'm not going to be able to increment any 500 errors when I do this, because the web server is still there and still active and still working. And then when the liveness check fails, what's going to happen is it's going to be pulled out of the running. And so any existing traffic will still be able to terminate, but no new traffic will go there. Pod will get rescheduled. It will come up on the new node, and it will enter the pool for availability again, which is a completely different lifecycle than what we saw on the left here, where I was not using healthy check or health checks or liveness checks to actually handle this. I was just shooting it and seeing what would happen, right? And so because it died out of hand, I'm able to see those error rates increment, which was interesting. So let's try this out on this guy. So this service is at 172.22.5.2. I'm going to fail the liveness probe. And because of the way liveness probes work, it's going to take a second for it to actually, it has to fail so many times before the system kicks in. And so we've lost 2 of them so far. And there it went. It got pulled out of the pool. We did not see any errors.
I saw one, yeah, there's like a 184 and a 3 for the 500s on the left.
On the left is a different thing.
Oh, I see, I'm sorry.
Yeah.
Oh, yeah, I see, sorry.
Yeah. I didn't see any errors increment on my right side, and now I'm back to 2 pods. And again, the reason that was is because the web server was still active. It was still able to service those requests, right? And then what happened is that there's like this time period wherein the pod itself is marked unhealthy, then it gets rescheduled to another node or to the same node, it gets restarted. And then when it comes back up, it gets thrown back into the pool. And so in this way, all I've done is have my availability. Like I only had, let's say I was able to get 1,000 requests per second per instance, right? If I kill off a pod, then obviously my availability goes down. I will be able to get 1,000, not 2,000. You kind of get the idea.
Yeah.
So that is the demo that I wanted to share with you. And again, like if you go to the Kind Chaos Cube repository underneath my GitHub name, Howie Lyon, all of that is documented okay here. You know, it's all here. Your Kind config is laid out here, how we're actually doing it. The README kind of talks about the instructions a little bit. It's not super well documented, but I think it's enough to get started with. So I hope that was interesting. That's what I got. Any questions or anything we want to try? I can totally get crazy here.
That was super interesting, Duffy. I really like that test. I thought that was a really awesome way to show off, like, one, this tool, which is a really awesome tool, but also kind of like one of the points of liveness probes and like the readiness checks and all those things, which I think kind of get looked over a lot. They're very valuable and useful tools in the Kubernetes, like
The probes, yeah.
Yeah, those probes, and people don't leverage them as much as I think that they could be. And that was a cool way to show off, like, yeah, we failed, we simulated a failure, but the system itself was resilient enough to manage in a way that the end user would not know about. That was so cool, really cool, dude.
Thanks.
We don't have a whole lot of time left, so I don't know if we can jump into another demo of anything. But does anyone have any questions around Chaos Cube? Nope. All right. Cool.
Cool,
I
yeah.
think that's basically all we have for chaos engineering for the Cloud Native Social Hour. Did everyone enjoy it? Did you guys gain some new knowledge, some new perspective? I know I did.
Absolutely. I think at least it gets us started in the right direction and look for options and way we could test our clusters. So that's definitely the takeaway for me.
Excellent. Anybody else on the line? Did you enjoy yourselves? Learn anything new? Yeah, that's fine. Yes, thanks everyone. By the way, if you haven't added your Twitter account or anything that you wanted to talk about more or anything in the HackMD, that should be available. We can add it to the chat, although I don't know how useful it is anymore. Jesse just bounced. Yeah.
Happy Friday to everyone.
Yeah, happy Friday, everyone. I hope you all have a great weekend. Thank you for joining us on the Cloud Native Social Hour. We will be picking this back up in a little bit. It's usually every fortnight, but I will be on vacation next week unless somebody wants to pick up hosting duty. I certainly wouldn't mind it continuing. There was something else I was going to say, and I totally just blanked on it. Oh well. Anyway, thank you so much, and I hope you all have an awesome weekend.
Thank you.
Bye.
Guys. Bye.